You're going to identify functions. So in the first part of your project, you're going to have to be able to identify linear, quadratic, exponential, rational, and square root by either equation and graph. Now the square root is actually what we were doing before we all left, was the radical equations. Those are the radical equations. That's what we were doing before we left. Okay, so I have attached this to your email, so hopefully you're looking at it, because I'm not going to spend a ton of time when you know you can read this, but I'm just going to give you the gist of all these functions. The linear function is a straight line. It has a constant rate of change. It means it goes up like a constant number and goes down a constant number, and the x doesn't have an exponent on it. So what you see is it's y equals mx plus b. So that's what your linear equation looks like, and then the graphs are lines. Quadratic, we just got done doing this with the remote learning in the beginning. It's called a parabola. It's a U-shaped graph. This should not be, hopefully not be too bad. It has a vertex, and we talked about where that vertex is. Right at there and there, all right? And then, of course, it's quadratic because it has an x squared. Everything else that follows just is the reason why the graph exists. But because it has an x squared makes it quadratic. Exponential is what we were talking about when we talked about compound interest and all that other good stuff earlier in the semester. They're L-shaped type of things, little graphs. They are curved. They're not straight. They get closer to this horizon, what they call an asymptote. They don't talk about that too much in your project, but it is something that you have to be aware of because it does get closer to it, which will affect max and mins when we get to it and stuff like that. And the main key here is the x is in the exponent. So as you can see here, it says 3 to the x. And then, of course, it could have a plus or a minus, or it doesn't matter. This one here is actually minus 2. But this is decay, of course. And this was, of course, growth. Sorry for the handwriting. All right. Rational functions, we solved these and we graphed them a little bit, found the intersections and stuff like that. We have to be able to identify it. This is the easiest to identify next to linear, in my opinion, because rational functions are the only ones that have two graphs in the same plane. So these are two separate curves. They have two asymptotes that they can't cross. So they have this two curve thing. And the big thing here is that the x is in the denominator, and there it is right there at the bottom. Anytime you see that, it doesn't matter how it looks, where it's at in the denominator, or if it even has like a 2 on it or a 4 on it, it doesn't matter. If there's an x in the denominator, it's called a rational function, and that will create these two curves. It actually can create more than that, but in our case, it creates two of them. This last one here is the square root function, or the radical function, and this is it forms like a half of a sideways parabola. And I don't know if you can actually see that, but I'm going to do this and then I'll erase it. But you see, if I connect it, it looks like a parabola. But we don't have to really kind of concentrate on that as much as it is pretty much a half a graph. It's just this part of a graph here that starts on the left and continues to the right. And of course, the square root thing is the biggest. It could be 3 the square root of 2x or anything like that. Still a square root, still a graph. It'll look like that. All right. So that's like the first part of your project. The next part of your project, you will have to be able to graph whatever function. Today we're going to do linear. And be able to identify the domain, the range, the x and y intercepts, and the max and min within its context. And I'll talk about that. We're talking about what the story that you're telling and the min and max in the story. So not just that it's going up forever, going down forever, all the numbers are included, but only what makes sense in the story. So I'm going to read this aloud. Please read with me. You have borrowed $540 from your parents to buy a mountain bike. Your parents are not charging you interest, but they want to be repaid as soon as possible. You can afford to repay them $20 a week. The situation is modeled by this P equals 540 minus 20W, where W is the number of weeks that we have, the number of weeks, and P is how much you have left to pay them. All right, so now that you have this equation, which is quite convenient, what we're going to have to do is we're going to have to graph this thing, okay? So it's easier on the project because you don't have to flip back and forth between your slides, but hopefully you have this in front of you somehow, print out or on the email or whatever. Anyway, so we're going to have to graph this, but it's a lot easier than you think, because really what you got to do is you got to go to a calculator. And when you go here into a calculator, remember this is my Calculator 84 on my Apple, or Wabbit EMU on your Android, depends, whatever. Also sent a link a while ago that if you have a computer, Texas Instrument was giving free downloads, so look for an email about that. Go to y equals 540 minus 20x. We use x instead of w because this is what it is. And then really, I mean, if you wanted to graph it, you can graph it. You're not going to see much. So what we're going to do is look at these tables more than anything. Now the graph, this says 0, 5, 40. You see my table here? 0, 5, 40 and 1, 5, 20 and 3, 500, stuff like that. So if we go back to the graph and we plot these points, we got 0, 5, 40, which is about like right there. Now, I'll be honest, I don't remember all the numbers. What did I say here? 10, 340 sounds like a good one to plot. 10 and then 340 is about right there, and so on and so forth. And then if you go into your here and you keep going down, you will end up sooner or later at 0. Now, I can't write on the calculator with my pen, but I'm highlighting it in pink here. That's 27, 0. That is a very important one to write down and to make sure that it is graphed. So I have this graph. I'm going to draw a makeshift line here because, you know, me and my straight lines. And there is the graph. So if I just go here, there's the graph. I did this so that it wasn't so messy, but there's our graph, all right? So we have this graph. You're going to have to do this today, but there's the questions. Here's the stuff you're going to have to answer, and they're not that bad if you just look at the graph and you take the scenario and you write stuff down. So I'm going to have to keep going back and forth, but know the graph is here for you, and then look here, okay? So it says here, what is the domain of the function considering the context of the scenario? Well, the domain of the function is what can x be? So I'm going to write that down underneath here. Domain means x, if you don't remember. So only the x's. Let's go back. Now I'm going to write here. All right, change my color to, let's say, green. X's goes from here to here. This is the x's, okay? So I say, okay, what can x be, right? So x can be from here, which is 0, all the way to here, which we said to write down was 27. So I go on to my next slide and I write down. Now this is going to be in what they call compound inequality notation, is that we are between 0, less than or equal to x. Oh, you know what? I have to do this correctly. It's w. No, you know what? Never mind. Let's leave it as x. It's fine. Let's leave it as x. It's fine. X and less than or equal to 27. This means, all right, so if you notice that they're less than or equal to, this means that x is between 0 and 27, which it is on the graph if you look at the green, 0 to 27 on the graph. We go to y. This is the range. This is y. The range says, well, considering the context, what can the range be? So let's go back, and I'll get a different color here. Let's go orange. And the range says I can go from here up to here, right? So the range starts at 0 down here and goes all the way up to 540 here, okay? Now, if you don't know where that 540 came from, if you go back to your calculator and you click all the way up to the 0, there it is right there in pink, 540, 0, 540. So that's the highest it can go before it gets to negative, because it doesn't make any sense to have a negative week. That's what we mean by in context. So we're going to go here, we'll go to the next slide, and we'll write our range down is from 0 less than or equal to y less than or equal to 540. Now, these two next ones, to me, I'm sorry, but are very, very simple. It's really, really easy. I'm going to change to my color red. I'm going to go back here. It says, what is the x-intercept and what is the y-intercept? These are super easy to find because it's right here for the y-intercept and right here for the x-intercept. And these numbers have already been written down due to domain and range. So if you find the domain and range, then you know the x and y-intercept. Pretty basic on the linear. So what is the x-intercept? The x-intercept is 0, 27, and the y-intercept is 500 and... I'm sorry about that. 1 second. I made a little mistake here. Sorry about that. We have x-intercept, which means it's, 27, 0, and this is 0, 540. Apologize for that mistake. Going too fast. All right, so the x and y-intercept, pretty basic, pretty easy to find. They're just wherever they hit the intercept. Now, it says, what is the min value and what is the max value? Now, maybe last year you were taught that min and max have to do with vertices or vertex, like on absolute value or quadratic. But the thing is, we are in context. So when we're in context, we're saying, what is the highest x that we have? Now, linear is the easiest because, again, it's the same answer. So, and lowest x we have. So, I'm sorry, lowest value we have. So when we go here, we say, okay, what is the minimum value? Well, look at this entire screen and tell me what the smallest number you see, and that is 0. And it says, what is the maximum value? Again, look at this entire screen, and what do you see? 540 is the maximum value. Now, if I go back, you'll see, if I look here, we talked about max and min. Let's go to, I don't know, do the blue. Here is the height, and here is the low. So how high did we go? 540. How low were we? 0. This changes with different functions, but with linear, it's easy. So that's why I kind of lumped everything together for today, and you have 6 problems to do on your project that should be pretty basic if you can figure that out. So these are y equals, but I don't think it matters. Okay, I need to erase that. It's too messy. So go ahead and do this. Again, we're talking about the project here that we have to do to get the credit for the course. So I'm breaking it up into 3 days. So today being Monday, you have 1 through 6. And then on Wednesday, we're going to do the same situation with scenarios and graphs, and you're going to do 7 and 8. And then on next Monday, you're going to do 9 and 10. All right. So that's that. That's it. And good luck on that project. As soon as you're done, send it. The faster you get it done, or well, I don't want it sloppy, but the sooner you get it done, the more you can concentrate on the next one, and so it's nothing behind. So don't forget the past stuff to still do, and then you got to get this project done. Okay? All right, have a good one.